Welcome back to my class. My name is Amara. I'm the physics teacher on Akadastor, and today we are continuing our investigation on our topic electrostatics. Today we're going to be looking at charged particles and electric field, electric potential. These have already been discussed in your lesson notes. Now remember that every discussion, the materials I'll be sending to you, all of them are on Akadastor. Your tests, your CBT tests, as well as the ones that are theoretical will be there. Then our discussions, like after this simulation, I'm going to be asking you some questions that I need you to think through before you give me an answer. I'll be dropping the answers of those two on our discussion page. So let's start off. I'm using PhET simulation. It's actually free, so you could go online too and get it and run some of these tests on your own. Okay, so um, this is a positive charge. First of all, we'll talk about some of the definitions that I gave you in your notes. Electric field. Electric field is the region around a charged particle. This is a positively charged particle. Now, all those regions, the regions around it is called an electric field. Now, if you notice that around this, the closer it is, the stronger the electric field is. But as you move away from it, it gets faint. All right. Then we said that positive like charges repel. The force between two like charges is a repulsive force. Now, if I bring this now to this place, you see, all of the electric field, all of the charges, they are pointing away from each other. There's no attraction between these two. So, like charges repel. If I put a negatively charged particle close to it, and you can see what happens. There's an attraction. The field is now moving from the positive to the negative. Remember, this whole area is the electric field, right? Now, electric potential. Electric potential is defined as the energy that a charge possesses, individual charge possesses in an electric field due to its position. The electric energy that a particle possesses in an electric field due to its position. Now, if I bring this particle right here and place here, remember, look at this whole place. Look at the electric field around here. All right. Now, if I put this charge here, apparently, of course, it's going to create its own field, but with respect to this other two charges that were already here, electric potential is telling you how much energy is available to this particular particle with respect to this due to its position. If I'm to bring it closer, I mean, commonsensically, that should tell you that the electric potential available to it right now should be more as opposed to when it was further away. Now, electric intensity. Let me put on the voltage so you can see. Now, if there are more charges here, watch what happens. If I put more charges around here, you see what happens. It tells you the intensity of the field, how strong the field is, the field that these several particles have created. This demonstrates it for you. Okay, so the more particles there are, and the closer they are, the stronger the field that they create amongst themselves. So you can run some of this and see how it works. Hold on. So you can play around with this just to see some of the behavior. If I say this is a space and I'm putting several charges here, how does it behave? What kind of force, what kind of electric field, see, will be created and what their different behaviors. This to this, you can see that there's an attraction. This is moving from this to this. Between this and this, there's a repulsion. You see, they are moving, they're pushing away from each other, this and this. Between this and this, there's an attraction. Okay, so like charges repel each other, unlike charges attract each other. So that just tells you, remember, electrostatics are charges that are stationary, and these charges that are stationary create electric fields, and the whole study of it is what you call electrostatics.